You've found Dreamtime Science, a peaceful corner where we unravel the mysteries of our universe one whisper at a time. Let the gentle current of discovery carry you towards sleep. You know what's fascinating? I've been thinking about glass lately, how something so clear and solid-looking can actually be a bit of a trickster when it comes to its true nature. There's something remarkable about how glass is made, and why it doesn't quite fit into the usual categories of solids or liquids, and I can't wait to share what makes it so special. It's a quiet kind of wonder that turns everyday windows into tiny mysteries when you look a little closer. Should these dreamy explorations accompany your journey to sleep, a gentle like or subscription would be deeply appreciated. What questions about our universe keep you wonderfully curious? Before we begin, create your sanctuary, nestle into your chosen spot, let your muscles soften, and allow your breath to find its natural rhythm. In the quiet hush of evening, when city lights flicker like distant stars and the world softens at its edges, there is a peculiar magic in gazing through a window pane. The glass, so mundane and ever-present, is a silent custodian between worlds, between the warmth of your room and the cool mystery of the night, between the present and the ancient past, between the known and the almost unfathomably strange. To speak of glass is to tell a story as old as civilization, yet as new as the next glinting smartphone screen. It is a tale woven through geology, alchemy, myth, and the restless, relentless curiosity of humankind. Tonight we embark on such a story told in silica, in shimmering surfaces and secret structures, in the marvel and enigma of glass. Pause a moment and consider the glass around you. Perhaps it is the window reflecting the dusk and the faint golden glow of your lamp, or a drinking glass on your table holding water that catches and bends the light in ways both simple and miraculous. Perhaps, too, it is the screen through which you read these words, so thin and bright it seems barely there at all. Glass is everywhere, and yet how rarely do we truly see it? How rarely do we wonder, not just at what it shows us, but what it is? Glass, as we use the word, is not a mineral, nor a true solid, nor a typical liquid. It is an in-between thing, a paradox, a material that stubbornly resists the urge to fit neatly into our categories. Its story begins with sand, the unremarkable grains that slip through your fingers at the shore, composed mostly of silicon dioxide, or silica. Heat that sand to a searing, almost otherworldly temperature, around 1700 degrees Celsius, and something remarkable happens. The grains melt, their crystalline order dissolving into a chaotic dance. But cool that molten mixture quickly enough, and the atoms, now unmoored from their regular lattice, freeze in a disordered jumble. The result is glass, not a crystal, not a simple liquid, but an amorphous solid, a kind of frozen liquid, its molecules locked in a perpetual state of arrested motion. At least that is the poetic version, and one that has fueled centuries of scientific wonder and public myth alike. In school, you may have heard the oft-repeated tale that glass is a supercooled liquid, that over centuries it will flow, ever so slowly, causing the bottoms of ancient window panes to thicken and sag. This image has a certain romance to it. Imagine the windows of medieval cathedrals sagging gently downward, time made visible in the very substance of the glass. Yet, like so many stories that delight the imagination, this one is more myth than reality. The truth is subtler and in its own way more wondrous. Glass is, for all practical purposes, a solid. It is rigid, brittle, and unyielding. Its atoms are not truly flowing, not even over centuries. Their jumbled arrangement is fixed, like a crowd frozen mid-dance. The thicker bottoms of old glass windows are not the result of slow downward flow, but of the manufacturing techniques of the time. Medieval glassworkers spun molten glass into flat discs, then cut panes from the edges, which naturally were thicker. When setting the glass into windows, the heavier side was often placed at the bottom for stability. Thus, the myth of flowing glass was born, a lovely echo of our yearning for the poetic, the mysterious, the idea that even the most solid things might, given enough time, become fluid. But the real mystery of glass is not in whether it flows, but in the nature of its in-betweenness, a solid with the disorder of a liquid, a material that is neither fish nor fowl, neither truly one phase nor another. Physicists call this the glass transition, a phenomenon that appears not just in silica, but in polymers, metals, even certain biological systems. The glassy state is defined not so much by what it is, but by what it is not crystalline, not mobile, not ordered, not chaotic. It is a pause, a holding of breath at the edge of chaos. Glass, then, is a metaphor as much as a material. It is the stuff of legends, fairy tales, and science fiction. In the ancient world, glass was precious, mysterious, almost magical. The Egyptians regarded it as a material fit for the gods. The Romans turned it into cups and vials, the color of the sky just after sunset. Glass beads, traded across continents, became a currency of beauty and exchange, glinting in necklaces and crowns. In the Middle Ages, stained glass transformed cathedrals into kaleidoscopes of colored light, painting stories in sunlight and shadow. Yet glass is also associated with fragility, with the thinness of the barrier between worlds. In folklore, glass is the material of mirrors, of portals, of enchanted barriers. The phrase, "through the looking glass," borrowed from Lewis Carroll's Surreal World, captures that sense of stepping through the surface into the uncanny, the unexpected. Glass both reveals and conceals. It is transparent, yet it is also a threshold. In science fiction and fantasy, glass is often a symbol of advanced technology, a future where walls themselves are screens, where information shimmers in the air, where the distinction between what is inside and what is outside is blurred. In the film The Glass Castle, based on Jeanette Wall's memoir, glass becomes a symbol of both aspiration and fragility, the dream of a shining, transparent home and the painful reality of dreams deferred. The castle of glass is both a promise and a warning, beauty that can shatter at a touch. But even in our everyday lives, glass is a silent companion to our aspirations. In the gleaming towers of modern cities, glass is both armor and invitation, a way to reach toward the sky, to let in the light, to see and be seen. In laboratories and observatories, glass is the eye through which we probe the secrets of the universe. The lens of the microscope, the mirror of the telescope, the fiber optic threads that carry our thoughts at the speed of light. Glass, in the form of optical fibers, has shrunk the world, allowing us to speak across continents, to send images hurtling through the dark. Yet for all its technological might, glass remains a substance of paradox. Its transparency is an illusion. It absorbs and scatters light, but in such a subtle way that our eyes are mostly fooled. Its strength is deceptive. It can bear tremendous weight, yet shatter at a careless tap. The reason lies in its structure, a jumbled, random arrangement of atoms that holds together only because the bonds between them are strong, yet once a crack begins, there is no ordered lattice to halt its progress. Glass breaks not smoothly, but with a sudden, catastrophic release, a shattering cascade that echoes the randomness of its internal world. And what of the myth that glass is a supercooled liquid, ever so slowly flowing? The idea is beguiling, but does not survive the scrutiny of careful measurement. If you could peer inside the atoms of a window pane, you would find them almost motionless, locked in their irregular embrace. The glass transition is a kind of kinetic trap. The atoms want to move, to settle into a more ordered state, but the cooling is too rapid, the energy too low. They are caught, like dancers who have forgotten the steps, forever poised and unchanging. Still, the myth persists, in part because it touches on something profound. Glass feels like it ought to be liquid, with its cool smoothness, its ability to take any shape. And the idea that the very substance of our windows might, over centuries, slowly flow, is a reminder of the deep time in which materials live. We yearn for a world where even the hardest things are not fixed, but mutable, where time bends the very stuff of reality. Culture and science entwine in glass as tightly as the silica bonds within its structure. In the ancient world, glassblowers were seen as alchemists, coaxing order from chaos, fire from sand. Even today, the making of glass retains a hint of the mystical, the furnace roaring, the molten blob glowing orange, the skilled hands shaping it with breath and motion. As the glass cools, it becomes solid in form, but not in spirit. It remembers the heat, the movement, the possibility of transformation. In the laboratory, glass is both vessel and participant. It holds reagents, withstands extremes, yet never quite yields its secrets. Its chemical stability is legendary, the reason it is used in beakers and test tubes, in the fragile pipettes that measure out drops of possibility. And yet, glass itself is prone to the slow work of water and air, to the whisper of chemical change. Over centuries, ancient glass can weather, turning cloudy, its surface etched by time. Even its famed transparency is no guarantee against the slow encroachment of the world. Glass is also the material of vision, lenses and mirrors, prisms and fibers, the optical wonders that have transformed our understanding of the universe. Galileo's telescope, Newton's prism, the giant mirrors of modern observatories all depend on the strange properties of glass. It bends light, not because its atoms are ordered, but because their disorder scatters and delays the photons, a dance of waves and particles at the atomic scale. And in fiction, glass is a recurring motif, a substance that divides and unites, that can be both weapon and shield. In Ursula K. Le Guin's The Dispossessed, glass is the barrier between worlds, between the utopian and the real. In fairy tales, a glass slipper is the key to transformation. In horror stories, the cracking of a mirror is a harbinger of doom. In every case, glass is both fragile and enduring, transparent yet impenetrable, a material that reflects our hopes and fears. The future of glass is as dazzling as its past. Scientists now create glasses that are stronger than steel, that conduct electricity, that change color with a touch. There is metallic glass, a strange alloy with the structure of a liquid but the strength of a blade. There are glasses that survive the blast of a furnace, that cloak their contents from view, that guide lasers with perfect precision. Each new form is a testament to the ingenuity of those who work at the edge of chaos, coaxing order from the random, beauty from the mundane. Yet, for all its technological marvels, glass remains at heart a mystery, a substance that is not quite one thing or another, a story that is never quite finished. It is the lens through which we see the world, and the veil that keeps the world just out of reach. It is the promise of clarity and the reminder that all things, even the clearest glass, contain secrets. And so, as the night deepens and the city lights blur through your window, consider the glass that stands between you and the darkness. It is more than a barrier. It is a threshold, a story, a question posed in silica and light. What more might we find if we step through the looking glass, if we allow ourselves to see not just the world beyond, but the strange, shimmering substance that frames our view? The answers lie in the depths of matter, in the history of fire and sand, in the restless quest to understand the stuff of dreams. But the story of glass, like glass itself, is only just beginning to reveal its true nature. Beyond its surface shimmer lie deeper mysteries, of structure and strength, of hidden order and secret weakness, of the ways glass can fracture and flow, reflect and refract. The next turn in our tale will take us inside the world of atoms and bonds, into the heart of brittleness and the paradoxical strength that glass can wield, a journey through the very fabric of this most enigmatic substance. The night awaits, and the glass, ever silent, is ready to show us more. There is a hush in the world of atoms, a silence so profound it feels as though it stretches back to the dawn of time itself. In that silence, if you could listen with the right kind of ears, you would hear a restless shuffling, a subtle, ceaseless dance. This is the dance of atoms, and nowhere is it more enigmatic, more quietly beautiful than in the strange heart of glass. Let us set aside for a moment the familiar comfort of glass as a thing, the cool weight of a tumbler in your hand, the glint of sunlight through a window pane, the delicate curve of a bottle's neck. Instead, let us diminish ourselves, shrinking downwards and inwards, past the realm of dust motes and pollen grains, past the jostling molecules of air, until we stand at last among the atoms themselves. Here the world is not smooth and continuous, but made of points and spaces, a realm of restless energy and improbable order. To understand glass, we must first remind ourselves of how matter is usually arranged. Imagine the classical solid, such as a crystal of salt or a shard of diamond. In these, atoms and molecules are arrayed in exquisite, repeating patterns, a lattice that extends, flawless and regular, from one edge to the other. Each sodium ion in salt sits precisely where it should, surrounded by an octet of chlorines, like dancers on a ballroom floor, every step choreographed and repeated, over and over, ad infinitum. This order is not an accident. It is the result of energy's relentless push towards stability. When a liquid becomes a solid, when molten rock cools into granite, or water freezes into ice, the jostling molecules lose enough energy to find their places in a rigid structure. The crystalline lattice is the physical embodiment of this surrender, a hymn to entropy's slow hand. But glass refuses that order. Glass is a rebel at the atomic scale. It is not a liquid, not by any common reckoning. It does not flow, not on any timescale meaningful to human life. Nor is it a true solid, for it lacks the repeating structure that defines a crystal. Instead, glass is what scientists call an amorphous solid, or non-crystalline solid. It is a material that stands perpetually between two worlds. To see this, envision a beaker of molten silica, the orange, glowing heart of sand made liquid by fire. At high temperatures, the atoms within this molten glass move with abandon. Silicon and oxygen tumble and swirl, forming and breaking bonds in a ceaseless, frenetic ballet. As the liquid cools, one might expect the atoms to settle into a crystal lattice, as water molecules do when forming ice. But under the right conditions, if the cooling is rapid enough, or the mixture just so, the atoms are denied the leisure to find their places. The dance is interrupted, the music stops, and the atoms are left frozen in a disordered array. This is the secret heart of glass. Its atoms are arranged as if they were still a liquid, but they are held in place, trapped by the sudden drop in temperature. Imagine a bustling city square, full of people milling and chatting, suddenly frozen in time. Each person stands where they were at the moment the clock stopped, not in neat rows or columns, but scattered, held in a living tableau of disarray. The structure of glass is just such a frozen crowd. Locally, there is order. Each silicon atom is bonded to 4 oxygens, forming little tetrahedral motifs. But globally, there is only irregularity, an absence of repeating patterns. This arrangement gives glass its strange hybrid character. On the macroscopic scale, it behaves like a solid. It is rigid, it resists deformation, it shatters rather than flows. But on the atomic level, it is more like a liquid that has forgotten how to move. The technical term for this is the glass transition. When a liquid cools, its viscosity increases slowly at first, then exponentially as it approaches a crucial temperature. For glass, there is no sharp, clearly defined melting point as there is with a crystal. Instead, there is a region, a temperature interval where the substance simply becomes so viscous, so resistant to flow, that it appears solid for all practical purposes. This is the glass transition temperature, and it is more of a suggestion than a law. Below this point, atomic motions slow to a crawl, but they never quite stop. Over geological timescales, millions of years, glass might, in principle, continue to relax, to rearrange itself ever so slightly. This is why some old windows in medieval cathedrals appear to be thicker at the bottom than at the top. For centuries, it was believed that glass must be flowing ever so slowly, like a river of congealed time. In truth, this is a myth. The unevenness is the result of the primitive methods used to create and install the glass, not a sign that it is sagging under its own weight. The atoms are, for all practical purposes, locked in place, their restless dance arrested. Yet the idea of flowing glass lingers in the imagination, a poetic image that hints at the underlying truth. Glass is a solid, but only just. It is not a state of perfect stillness, but a compromise, a truce between the order of the crystalline and the chaos of the liquid. The technical language used by scientists is amorphous solid, but even this is not quite satisfactory. Amorphous means without shape, but glass has a shape, a window, a vase, a lens. What it lacks is periodicity, that regular repetition that marks the crystalline. To probe more deeply, let us look at the structure of glass at the atomic scale. The most familiar glass is made from silica, or silicon dioxide, the same basic chemical that makes up quartz. In crystalline quartz, each silicon atom is joined to 4 oxygens in a rigid, repeating tetrahedral network that extends in all directions. In glass, the basic building blocks, the silicon-oxygen tetrahedra, are still present, but they are connected in a haphazard, non-repeating fashion. The tetrahedra are linked, but the angles and distances between them vary at random. There are no planes of cleavage, no neat faces, no internal symmetry. This randomness is not just a curiosity, it is the source of glass's most remarkable properties. The absence of long-range order means that glass does not have the same weaknesses as crystals. It lacks the slip planes along which crystals can fracture, making it both brittle and, paradoxically, strong. When glass does break, it shatters, distributing its energy in a chaotic spray of fragments. Its smoothness and transparency, its resistance to weathering and corrosion, all stem from this disordered arrangement, and yet the story does not end with silica glass. The world of amorphous solids is rich and varied. Add a pinch of sodium carbonate, and the glass becomes easier to shape, its melting point lowered. Add calcium oxide, and the glass becomes more stable, less prone to dissolve in water. The recipe can be tweaked in 100 subtle ways, each change reflected in the microscopic jumble of atoms. Some glasses are colored by the inclusion of trace metals. Cobalt yields a deep blue, chromium a soft green, gold a radiant ruby. Each color arises not from pigments or dyes, but from the way the glass's disordered structure interacts with light. This disorder is not complete chaos, however. At the smallest scale, there is still a kind of order, a short-range regularity. If you were to examine a tiny patch of glass, just a few atoms across, you would find that each silicon atom is bonded to 4 oxygens, and each oxygen is shared between 2 silicons, forming a web of tetrahedra. But step back, widen your gaze, and the pattern dissolves into randomness. It is as if the atoms remember the rules for a few steps, then forget them entirely. Scientists have developed ingenious ways to probe this hidden architecture. X-ray diffraction, so useful for mapping the neat rows of crystals, yields only a diffuse, featureless pattern when aimed at glass. Neutron scattering and nuclear magnetic resonance provide glimpses into the local environments of atoms, revealing the persistence of the tetrahedral motif. Computer simulations trace the cooling of a virtual liquid, showing how the atoms slow, jostle, and finally freeze into a glassy tangle. The boundary between solid and liquid, then, is not as sharp as we once imagined. Glass occupies a liminal space, a twilight realm between states. The distinction between crystalline and amorphous, between order and disorder, is not a matter of black and white, but of degrees and gradations, and glass is not alone in this. Many materials can form amorphous solids. Certain metals, called metallic glasses, can be cooled so rapidly that their atoms are trapped in disarray. Some polymers are glassy at room temperature, only becoming soft and rubbery when heated. Even water, under the right conditions, can form a glass, a brittle, transparent solid known as amorphous ice. Why, then, is glass so stable? Why do its atoms not simply rearrange themselves into a crystal over time? The answer lies in the landscape of energy. Imagine the arrangement of atoms as a marble rolling across a landscape of hills and valleys. A crystal is a deep valley. The marble settles there easily, content in its lowest energy state. Glass, by contrast, is a marble trapped in a shallower depression, unable to reach the deepest valley because a hill, the energy barrier, blocks the way. The atoms in glass are caught in a local minimum. To find a more ordered arrangement, they would have to climb over an energy barrier, a feat that is vanishingly unlikely at ordinary temperatures. This, too, is part of the enchantment of glass. Its stability is a kind of kinetic trick, a triumph of slowness. The atoms are not exactly at rest, but their journey toward equilibrium is so slow, so patient, that for all our lifetimes and beyond, the glass remains unchanged. The world of glass is one of arrested motion, a snapshot of disorder made permanent. And so, as you gaze through a window or hold a glass to the light, remember that you are not looking at a simple solid, but at a material with a secret. Its atoms are locked in a perpetual dance, a choreography that began in the heat of the furnace and was frozen in the moment the glass cooled. It is a material that defies easy categorization, that lives in the spaces between, a testament to the subtlety and complexity of the physical world. Yet mysteries remain. If glass is a frozen liquid, why does it shatter so suddenly? How does its atomic disorder translate into the sharp edges and smooth planes of a broken shard? What secrets lie in the fracture, in the very failure of glass to hold together? These questions lead us onward, into the realm where the strength and fragility of glass are revealed, where the interplay of atoms and energy determines not just what glass is, but how it breaks, sometimes with a whisper, sometimes with a song. Across the ages, the alchemy of sand into glass has stood as one of humanity's most enchanting and enigmatic achievements. In the hush before dawn, when the coals of ancient fires still glowed and the desert winds whispered secrets, the earliest glassmakers gazed into molten pools of possibility. They could not have known the depth of mystery they were stirring with their long iron rods, nor the worlds of science and artistry that would unfold, layer by shimmering layer, in their wake. To understand this transformation, let us begin at the shore. Humble grains of quartz, born of mountain and river, tumbled by time and tide, gather in drifts along the water's edge. Each grain is a relic of geological patience, composed chiefly of silicon dioxide, SiO2, arrayed in a rigid lattice as hard and clear as ice. This sand, so ordinary beneath our feet, conceals within its structure the potential for transparency, for color, for capture and release of light. Yet the leap from granular opacity to gleaming pain is far from trivial. It requires the intervention of heat, a conjuring fire so intense that it undoes the ancient bonds holding each grain together. The earliest glassmakers, perhaps Phoenician traders or Egyptian artisans, might have first witnessed this transformation by accident. A campfire, built atop sand and stoked with the ashes of plants rich in soda, may have left behind odd, greenish lumps, glassy remnants, smooth and brittle, unlike any stone or crystal. Human curiosity, that most persistent of flames, would have urged a closer look. What if this could be repeated? What if the process could be understood and then bent to the will of the maker? The first step in the alchemy of glass is the careful selection and mixing of materials. Pure quartz sand, while beautiful, is stubborn. Its melting point is over 1700 degrees Celsius, hotter than most early furnaces could reach. To coax the sand into a more tractable state, ancient glassmakers discovered the power of fluxes, substances that lower the melting temperature. Soda, derived from the ashes of halophytic plants, or potash from wood ash, could be blended with sand to create a workable mixture. Lime, often introduced as a stabilizer, prevented the resulting glass from dissolving in water. Over the centuries, these recipes became ever more refined, an evolving chemistry passed from hand to hand, generation to generation. Once mixed, the raw ingredients are introduced into the crucible. Here, under the watchful eyes of the glassmaker, the true transformation begins. The furnace, a roaring heart of flame, devours the mixture in its embrace. At first, the sand resists, its silicate lattice clinging to order. But as the temperature rises and the fluxes work their subtle influence, the structure begins to fail. Bonds break, molecules tumble, and the mixture flows. What emerges is an amorphous liquid, a molten glass, neither fully solid nor liquid, viscous and glowing, like the sun's own blood. The glassmaker must work quickly, for this molten phase is fleeting, and the window for shaping is narrow. In the earliest days, glass was poured into simple moulds, forming beads or small objects, but over time a more elegant and versatile technique emerged: glass blowing. To witness a master glass blower at work is to watch a dance of breath and flame, a choreography of timing and touch. The artisan gathers a blob of molten glass onto the end of a hollow tube, rolling it on a smooth stone or metal surface called a marver. With a steady, practiced breath, they blow into the tube, inflating the glowing glass like a soap bubble. The sphere expands, walls thinning, until it is coaxed into the desired shape by turning, swinging, or even gravity's gentle pull. Tools of every kind, shears, paddles, pincers, come into play. The glass, still malleable, responds to the subtlest pressure, yet cools rapidly. The dance is one of constant adjustment, reheating in the glory hole furnace, stretching, pinching, spinning. Colors are introduced by adding metal oxides, cobalt for blue, manganese for purple, gold for ruby red. Patterns swirl as layers of differently colored glass are fused and twisted, creating marbles, vases, goblets, and, eventually, window panes and lenses. One cannot overlook the marvel of Venetian glass blowers, whose secrets have echoed down the canals of Murano for centuries. Here, the craft became both science and art, with families guarding recipes and techniques as jealously as alchemists protected their formulas. The glassblowers' guilds were sworn to secrecy, their members forbidden to leave the island lest they reveal the mysteries of Cristallo, the clearest, most flawless glass of its day. Their mastery gave rise to innovations like filigree, millefiori, and aventurine, each a testament to the interplay between chemistry, heat, and human ingenuity. Yet glassmaking is not only the domain of artisans, but also of scientists who seek to unravel its structure and behavior. To study glass is to engage with paradox. Unlike crystals, with their ordered, repeating patterns, glass is a solid whose atoms are locked in a disordered dance, frozen in the chaos of the molten state. It is a supercooled liquid, some say, though this is not quite accurate. Rather, it is an amorphous solid, its molecules held fast by bonds that have no symmetry nor periodicity. To peer into this invisible world, scientists have developed ingenious tools. X-ray diffraction, so useful for crystals, yields only a diffuse, featureless halo when aimed at glass. Instead, spectroscopic methods, Raman, infrared, and nuclear magnetic resonance let us probe the vibrations and arrangements of atoms within. Under the microscope, fragments of ancient glass reveal weathering and corrosion, rainbows of iridescence, the work of centuries of slow chemical change. Modern electron microscopes can image the very surfaces where silica meets air, while computer simulations attempt to model the endless variations of atomic linkage. Experiments abound. In one, a drop of molten glass is allowed to cool at different rates. Cooled quickly, the atoms have no time to find order, and the glass is clear, strong, and, to the eye, homogeneous. Cooled slowly, crystals may begin to form, devitrification, spoiling the transparency, introducing opacity and brittleness. The rate and manner of cooling, the presence of impurities, and the ratios of ingredients all conspire to determine the final properties of the glass: its hardness, its color, its ability to bend or shatter light. The creation of window glass, a feat we now take for granted, was itself a triumph of technique. Early panes were spun flat from blown cylinders or crown glass discs. Later, the float glass process, invented by Pilkington in the 20th century, revolutionized production. Molten glass poured onto a bath of liquid tin, where it spread in perfect sheets, free of distortion or ripple. This innovation made possible the glass facades and endless windows of modern cities, transforming skylines and, in a way, the very experience of interior and exterior space. Even as we marvel at human craftsmanship, nature herself is not without her own glassworks. Lightning striking a sandy beach will sometimes create fulgurites, hollow tubes of vitrified sand, their inner surfaces glazed and smooth, testaments to a brief, fierce heat. In the heart of volcanoes, obsidian forms as lava cools too quickly for crystals to grow, a volcanic glass prized for millennia for its sharpness and deep, glossy black. Meteorite impacts, too, can melt the crust, forming tektites that rain down far from the site of their creation, alien glass scattered across continents. The study of ancient glass artifacts, painstakingly excavated from burial grounds and shipwrecks, offers clues to the trade routes, technologies, and daily lives of vanished peoples. By analyzing trace elements and isotopic signatures, scientists can sometimes trace the origins of the sand used, the recipes followed, and the journeys taken by beads, vessels, and windows. Each fragment is a message from the past, encoded in chemistry and form. In the laboratory, glass is a playground for experimentalists. One may attempt to trap gases or tiny particles within its matrix, preserving bubbles of ancient air or the fleeting signatures of nuclear reactions. Glass fibers, drawn so thin as to be invisible to the naked eye, can carry streams of light. Optical fibers forming the backbone of our global communication. Specialized glasses, doped with rare earths or engineered for specific wavelengths, become the lenses and prisms of telescopes and lasers, bridges to the distant and the infinitesimal. But always, at the heart of it all, is the fire. The furnace, glowing orange and white, is both crucible and muse. Its heat must be mastered, its caprice respected. The glass blower, with hands calloused and eyes attuned to color and viscosity, is both scientist and artist, conducting experiments anew with every gather, every breath. Each piece is unique, shaped not only by recipe and technique, but by the ineffable qualities of moment and motion. Consider for a moment the paradoxical fragility and strength of glass. It can be shattered by a careless blow, yet certain forms, tempered glass for example, are almost unbreakable, their molecules locked in tension. Prince Rupert's drops, those teardrop-shaped glass beads, are a famous example. Their bulbous heads can withstand hammer blows, but a tiny nick at the tail triggers explosive disintegration. This, too, is a subject of experiment and wonder, a visible reminder of the hidden stresses and structures within. even the clarity of glass, so easily taken for granted, is a triumph of control. Each impurity, iron, manganese, sulfur, imparts a tint or cloudiness. Ancient glassmakers often stumbled upon decolorizers by accident, adding manganese dioxide to mask greenish hues or antimony to clarify. Modern float glass owes its transparency to rigorous purification and exacting control over composition and temperature. Throughout this long lineage, tools have evolved and multiplied. The blowpipe, the pontil rod, the marver, and the shears, the pot furnace, the annealing oven, and the moulds of iron, bronze, or wood. Laboratories bristle with spectrometers, calorimeters, and computers humming with simulations. Yet even now, in the most advanced factories or the humblest studio, the essential act remains the same: the transmutation of sand by fire and will into something that captures and transforms the world's light. And so, as we contemplate the genesis of glass, we find ourselves at the crossroads of many disciplines: geology, chemistry, physics, art, and history. Each pane, each vessel, each glittering bead is a convergence of nature and knowledge, accident and intention. In the studio's heat, in the lab's quiet, in the glint of a window at sunset, the story of glass continues to unfold, a story written in the language of atoms, of color, of light. As the embers of the furnace dim and the newly shaped glass cools in the annealing oven, its stresses easing, its structure settling into silent disorder, we peer forward, wondering what further mysteries this ancient material might yet reveal. For though we have learned to coax beauty and utility from molten sand, the true depths of glass's secrets remain, as ever, just beyond our grasp, shimmering in the half-light between certainty and wonder. Glass, that silent and unassuming companion, drifts through the tapestry of our lives like a whisper of moonlight upon still water. It stands between us and the world, a gentle membrane that neither confines nor separates, but rather invites us to gaze onward, outward, and sometimes inward. From the flickering warmth of a candle lantern to the probing gaze of the telescope, glass weaves its subtle thread through centuries of human longing, discovery, and wonder. Consider for a moment the paradox that glass embodies. It is at once strong and delicate, ancient and ever new, invisible in its clarity, yet omnipresent in its influence. Its very existence challenges easy categorization. Solid, yet not crystalline, rigid, yet not fixed in the molecular order of true solids. Glass is a snapshot of molten chaos, frozen in an uneasy truce between structure and disorder. To hold a pane of glass is to hold a moment captured from the fluidity of fire, a relic of molten sand stilled at the threshold between liquid and solid, resting in a state physicists call an amorphous solid. The atoms within, forever restless, are locked in place not by the symmetry of a crystal lattice, but by the sudden chill of cooling, a shivering hush that denies them the comfort of order. Yet, through this disarray emerges an extraordinary property: transparency. The world beyond the window is not hidden, but revealed. Light, that ancient traveller, passes through the tangled atomic forest, scarcely impeded, scattering only faintly, permitting vision without distortion. Glass, for all its internal tumult, is a peacekeeper between worlds, the inside and the outside, the known and the unknown. It is tempting to think of glass as a mere tool, a passive conduit for human ingenuity. But to do so is to overlook the poetry embedded in its presence. Glass is the silent collaborator in countless human dramas. It has guarded the humble candle's flame against the wild breath of wind, allowing the scholar to read deep into the night. It has, since the earliest windows, transformed dwellings from dark enclosures into sanctuaries of light, reshaping the very architecture of our homes and our dreams. Through its panes, cold winters are softened by the glow of morning sun, and the sharp bite of the world is gentled by a protective boundary that does not sever us from nature, but frames it, inviting contemplation. Even in its simplest forms, glass is a vessel for hope. The bottle that cradles water or wine, the lens that grants sight to those whose eyes falter, the beaker that holds a chemist's experiment, trembling at the edge of discovery. Glass has been the envelope for messages, the boundary for aquariums, the shimmering skin of greenhouses where life flourishes out of season. It has preserved the written word upon stained panes in cathedrals, casting rainbows across stone and soul alike. Yet perhaps nowhere does the magic of glass manifest so powerfully as in its role as an instrument of vision. Its transparency, coupled with the subtle curve of a lens, has given us eyes that see beyond the limits of flesh. Through the telescope, the distant shimmer of Saturn's rings and the faint glow of ancient galaxies have entered human consciousness, not as myth or rumour, but as facts, as wonders to be mapped, measured, and pondered. The microscope, its sibling in purpose, unveils the hidden universes within a droplet of pond water, a flake of skin, a grain of pollen. Each is a revelation of worlds within worlds, made possible by the gentle bending of light through glass. There is a quiet democracy in glass. It does not discriminate among those who peer through it. The same pane that frames the dew-laden garden for a poet also reveals opportunity or threat to the wary sentinel. The lens that magnifies a rare manuscript for the scholar does so without prejudice, asking only that the eye behind it be curious. Glass, for all its sophistication, is fundamentally accessible. It is sand, transformed by fire, shaped by breath and hand. It is the product of art and science, of necessity and imagination. One cannot help but marvel at the humility of its origins. The quartz sand that lines the beds of ancient rivers, the plant ash or soda that softens it in the furnace, these are not rare or precious in themselves, but under the artist's breath, through the alchemy of heat, they are reborn as something greater than the sum of their parts. The glassblower's pipe, gathering a glowing orb of molten glass, is an instrument of both craft and creation. The breath that inflates the molten bubble is a gentle echo of creation stories, a human exhalation that brings forth form from formlessness. In the hands of artisans, glass becomes a language of beauty. Venetian glass, spun into lacework filigree or suffused with colour, dances with light in a silent symphony. Stained glass windows, their pigments bound within the matrix, transform sanctuaries into kaleidoscopes of spirit and story. Each fragment is a fragment of story, the cobalt blue of a medieval Madonna, the ruby red of a martyr's cloak, the green of paradise regained. The sunlight that pours through these windows is not merely illumination, but revelation, a shimmering reminder that the ordinary can be transfigured. Yet glass is not without its shadows. It is often seen as fragile, its breakage a metaphor for the vulnerability of all things beautiful. The shattering of a glass pane is abrupt, final, a sudden end to transparency, a scattering of sharp-edged reminders that nothing lasts forever. And yet, even in its brokenness, glass is instructive. The fragments reflect the world in new ways, scattering light into unexpected patterns. Some are gathered and reassembled as mosaics, their former unity reimagined as a new whole. In this, glass teaches us that resilience and fragility are not opposites, but companions, each giving meaning to the other. The story of glass is also the story of secrets unveiled and mysteries deepened. Its transparency is not merely a physical property, but a metaphor for the human desire to see and understand. Yet, for all that glass reveals, it also conceals. The glass of a mirror is paradoxically both window and wall, a surface that returns our gaze but refuses to let us see beyond. The surface of a lens is a threshold, promising clarity, but always subject to the distortions of focus, perspective, and the inherent limitations of vision itself. In the laboratories of the modern world, glass remains indispensable. The test tubes and flasks of chemistry, the fiber optic cables that pulse with digital information, the photonic crystals that manipulate light at the edge of possibility, each is a testament to glass's ability to adapt, to serve, to inspire. It is a material that both contains and conducts, a vessel for experiment and a pathway for knowledge. The philosophical resonance of glass extends even further. It is, in a sense, a metaphor for the human condition. We are, each of us, creatures of transparency and opacity, of clarity and confusion. We seek to see and to be seen, to reveal and to remain mysterious. Glass, with its capacity to let light pass or to reflect it, mirrors our own struggles and aspirations. Its surfaces are sometimes clear, sometimes clouded. Its forms are sometimes flawless, sometimes marred. Yet through all its transformations, it remains fundamentally the same, a medium through which light and life persist. There is a quiet courage in glass, too. To exist at the edge of order and chaos, to bear the stresses of wind and weather, to serve as both barrier and bridge, these are not trivial feats. The skyscrapers that shimmer above city streets clad in glass are testaments to the material's strength and versatility. They gather the sun by day and the city's lights by night, becoming lanterns of human ambition. Within their walls, people are both sheltered and exposed, participants in a drama of transparency and privacy. Through glass, we have extended our senses, amplified our reach, and deepened our understanding of the universe. The Hubble Space Telescope, floating on the edge of the atmosphere, is little more than a careful arrangement of mirrors and lenses, yet it has brought us images of galaxies born in the dawn of time. The eyeglasses perched on a child's nose are a simple technology, but they are also a passport to participation, to learning, to seeing the world in all its detail. Even in the digital age, where light pulses not just through air, but through strands of glass as thin as a human hair, glass remains the silent partner in our communication. Fiber optic cables, spun from pure silica, carry voices and images across oceans and continents. The screens that flicker with words and pictures are sheets of glass, their surfaces alive with the dance of pixels. In this way, glass is the thread that binds us, each message, each image, each glimpse of distant reality, born on the delicate shoulders of a material that began as sand and fire. There is perhaps a lesson in the ubiquity and modesty of glass. It does not demand attention, yet it is everywhere. It does not shout, it whispers. It does not confine, it frames. It is not an end, but a means, a way of seeing, of connecting, of dreaming. In its silence, it invites us to look anew at the world and at ourselves. As you drift towards sleep, consider the journey of glass from the fiery furnace to the cool quiet of your window pane. Imagine the light that travels through it, the images it has shaped, the knowledge it has enabled. Reflect on its resilience in the face of storm and time, its vulnerability to the sudden blow, its capacity to endure and to transform. In glass, we see not only the world beyond, but the workings of human hands and minds, our longing to understand, to beautify, to connect. And so the story of glass continues, its thread weaving through the fabric of civilization, luminous and unbroken, drawing us ever onward toward the mysteries that still lie hidden, just beyond, waiting to be revealed. And so our journey through the shimmering realms of glass gently drifts to a close, like a comet tail fading into the hush of space. As we ponder the delicate dance between solid and liquid, may your thoughts float peacefully among stardust and quiet wonder. Rest easy, And when your dreams seek new mysteries, return with us to wander once more through the endless night of discovery.